So welcome to Keeping Secrets for iOS Developers. My name is Randy Biter. I recently... Thank you, Mark. Thank you. I have a cheering squad here. My name is Randy Biter. I just recently started a company called Plug Studios doing mobile development. I've been doing iOS development for 2.5 years. Recently started getting into Android development. This talk is going to be mostly about the iOS platform, but we're going to talk about some topics that will be relevant to whatever mobile platform you're doing development for, and development in general, really. How many of you guys have done any iOS development or interested in iOS development? Cool. Okay. iOS, for the rest of you guys, is, they used to call it iPhone OS when it was just the iPhone. They had the iPod Touch under that, then the iPad. They finally renamed the OS to be a little more relevant to all of the platforms that it runs on. The goal for this talk is better security for applications intended for the application store. There's a lot of topics around the jailbreak platforms that we won't really be touching on. This is mostly for apps that follow Apple's guidelines and go up on the App Store and trying to keep your resources secure within those. Therefore, most of the statements that I'll be making about the iOS platform and about the restrictions and the security measures that are in there are mostly assuming that you're on a stock device. So there's a balance in any security where you want to balance the usability of the solution that you end up with the security. And that's going to depend on what you're trying to secure and what the nature of your application is. Complicated two-factor authentication with a strong password probably isn't necessary for a Twitter application. At the same time, you probably, if you're doing an e-commerce application, don't want to store credit cards in the clear in a plist file in your documents directory. So there's a balance there. You want to keep in mind the domain that you're working in when you choose a security mechanism. It can be challenging to hide any kind of strong keys in your application. An application binary is encrypted, but once your binary is cracked, which if you have an application that's even remotely interesting to the rest of the world, it'll end up being cracked at some point. Any information that you've stored within the binary isn't encrypted at that point. And any other resources that are in your application bundle aren't encrypted to begin with. So even if your application isn't cracked, a lot of resources that you may think are protected by the signing process are not. And we'll get into some specifics of that in a little bit. Unless your application is completely security-centric, is financial, medical, anything that is really, if you're protecting data for your user as the purpose of your application, most of the focus that you're going to be doing is on making things not obvious, making it a little bit harder rather than completely secure. If your security is if your application is security-centric, you're going to want to keep as many of the secrets off of your device as possible to make it a little bit harder to give another layer that an intruder has to break into in order to get at your information. Tie secrets to your user and keep authentication off on the server side if you've got a really secure application, because that makes it a lot harder to attack the device, attack your application directly without having to involve attacking your server side. Remember, the old adage applies: if a man or a woman made it, then a man or a woman can break it. You've got to assume that your information is not going to be secure. If you start there and work backwards, you're going to be a lot better off. You need to seek to expose as little as possible in the event of a security breach, because if it's worth breaking into, it will be broken into. And you want to obscure the details to make casual browsing less fruitful. So the harder it is, in a crowd like this, it's probably going to be taken as a challenge, but you also want to you want to try to make it so that it's not terribly easy either. There's a balance there. Code signing. So unmodified devices can generally only run applications that are signed either by Apple or by a developer account, an enterprise program, anything like that. Applications are signed by Apple when they go through the application store. As an iOS developer, you can also sign an application for use on development devices or on what they call ad hoc devices. So you can distribute betas, that kind of thing. Code signing is not encryption for your data. Anything that you include in your application bundle is not encrypted. It encrypts the binary, so any static strings that you have in your source code will at least be obscured by the binary that Apple ships out, not in any ad hoc builds that you do, but in the binary that Apple actually ships through the App Store. The only problem is that once an IPA has been cracked, those strings aren't encrypted anymore. So you can run strings against the binary, you can look at it, you can hook it up to a debugger, look through it, and any of the information that you were expecting to be protected by that signing is going to be laid bare. It doesn't prevent unauthorized modification of items in the application sandbox. So an application running on a stock device has access to 3 main directories that you can store application data in. One is the documents directory for that application. You've got the caches directory, and you've got the temporary directory. All of those directories are easily visible on an unmodified device using a program called iPhone Explorer. In general, the only directory that's explicitly copied over to the user's computer during iTunes backup is the documents directory, but the caches and the temporary directories are also exposed by a tool that you don't actually have to jailbreak the device to be able to use this tool. And you can not only look at the items, but you can also modify them. The IPA files distributed by the application store are just renamed zip files. The zip file contains the binary for your application. It contains any resources that you include in your application, so any images, any sound files, any level data, anything is in there. It also includes the code signing. But the fact that an IPA file is just a zip file is unaffected by the code signing process, and it still acts like a zip file. Code signing is a mechanism to prevent unauthorized applications running on stock devices. So an unsigned application or an application with invalid signing won't run on a device. Applications, so Apple does encrypt the application binary when it goes through the App Store, but there's various mechanisms to get that unencrypted again. And unencrypting that is part of the cracking process if users are using a cracked version of your application, whether it's a pay-for application. Even free applications need to worry about this, especially if they're doing anything financial, anything e-commerce. There's more than likely incentive to crack free banking applications to see if there's any exploits in those that someone could leverage. So even if you've got a free application, you should still consider the fact that it could be cracked to expose any details that you were expecting to be hidden by that application signing. Changes to the bundled resources within a signed application will cause the application to be invalidated. Early builds of the iOS operating system allowed you to change the default ping file. So when you first launch an application on the iOS platform, an image is popped up before your application actually starts running. That's the default screen, splash screen, whatever you want to call it. Applications were able to change that to have a different screen come up every time. That was actually pretty bad from an application signing standpoint, because it meant that the application signing wasn't invalidated by changes to files in a particular portion of your bundle. They sewed that up a few versions ago, but it's that kind of thing where that should have broken the signing but didn't at the time. The last thing that code signing really strives towards is to try to prevent or curtail piracy, relying on the fair play authentication. There are methods out there to try to detect within your application if the binary has been cracked, and maybe pop up a message encouraging the user to buy the actual version. It's just like any other anti-piracy mechanism. If someone is motivated enough to get around it, someone's going to get around it, and it becomes a cat and mouse game. There's a couple of different mechanisms. You can check the info P list. In unsigned or a binary that's been re-signed by the cracking process will have a property in the info P list that you can check for, signer identity. There's also mechanisms out there. I saw a website that had a toolkit that you could use, or a couple of methods that you could check to see if the main function of your application is still running in an encrypted space. Like I said, for as many ways as there are to try to decide if the application is cracked, all it takes once the application is cracked is to go through the debugger and find where those points are and break around them. So it's like as far as trying to prevent piracy, it's like any other aspect of security where you need to kind of balance how much time you put into trying to get around it or trying to prevent people from getting around it to what the core purpose of your application is. You need to be aware of who you're protecting and from whom. You may be, the obvious one is to protect the user's data. So you don't want the user's data to be exposed either unintentionally or in ways that they wouldn't expect or in ways that compromise their security. But people are also going to try to crack your application, going to try to get into the internals of your application. You should also assume that if you're talking to a remote server, that people will be interested in seeing what the communication with your server is like and see if there's any ways to affect that. You want to protect, like I said, you want to protect your application from the user as well as the user's data. If you assume everyone is out to get everyone else, you'll probably be in a good place in the long run. Assume that someone will obtain your user's device without their blessing, so get access to the actual physical hardware. Assume that people will be able to get access to your user's iTunes backup and they haven't been smart enough to turn on encryption for the backup so everything's stored in the clear. Assume that someone's going to get hold of your IPA and they're going to either get a cracked version of the binary or they'll just use the IPA as it stands and get access to any resources that end up that you bundle with your application. Assume that someone's going to try to sniff the traffic between your application and any back-end servers that you communicate with. And assume that they're going to use the information that they gained for fun and profit. You have to strive to protect both the user's data and your application's data. You also want to protect the communications with remote servers. The integrity of your server-side data, if your API doesn't protect against the deletion of records, the changing of records, it's easy when working on a mobile platform, and it feels pretty closed down. It feels like a sandbox. There's no URL at the top of the screen that's screaming for a user to try to manipulate it. It can be easy to assume that all the communications and all of the requests that are going against your server are going to be legitimate. They're coming from the application. You don't have to check bounds. You don't have to check authorization in addition to authentication. But doing that can leave you open for a lot of bad problems. Once somebody figures out what kind of protocol you're using, what the parameters are, and starts tweaking those parameters. You also want to check, so in addition to, to authorizing the actions that a remote client is using against your server, you also want to prevent, you want to keep the type of data that you're communicating back to the server to be what the client should be telling you about. So if you've got a multiplayer game, you should be accepting requests from the client to tell you where the user wants to move to. You don't want to send the entire map of what the game looks like and expect the user, the client, to be honest about it. So in a chess game, you might say, I'm moving this piece from this point to this point. You don't want to pass the whole chessboard back and have the user be able to move around pieces, any of them, beyond just what that move called for. For an ordering system, you want to take information from the client that the client should know about. Accept the client telling you what product item that they want to buy and how many, but don't accept a price from the client. It can be easy, it can seem innocuous to take that, but somebody can tweak the value and buy things for what they shouldn't be sold for. You also want to check out for messages claiming to be from a different user. So if you're just passing along an action and a user ID, make sure the user ID actually matches up to who you authenticated the user as. If you're posting a tweet, say, and you're writing the back end, don't just accept a Twitter ID and a message. Actually check to see that the Twitter ID matches up with who the user says they are, or don't even pass the Twitter ID to begin with. If you already know who it is, just take your data over the clients wherever possible. If you examine the files and the strings in your application bundle before shipping them, so when you build the app bundle and send it over to Apple, your binary isn't going to be encrypted yet. So if you run the strings command against your binary, you'll be able to see all of the text strings that are in your application that a user will be able to see if they crack your binary. So any passwords, any URLs that you use, any secrets you have contained in there will be just as bare to the user if they're looking at a cracked binary. As I said before, the application binary is encrypted. Cracked IPAs are going to be in the clear. P-lists that are in your application bundle are compiled from their XML form to a binary form, but they're not encrypted at all. You can still open them up in the property list editor, and you can still see all the values in there. I said you want to run the strings command against your binary to see exactly what you could potentially be exposing. You can release the browsing of passwords and string resources in your binary using pretty lightweight techniques. It's not going to stand up to someone actually using a debugger, actually examining and running through your application instruction by instruction, but simple base 64 encoding or some other type of encoding. If you split strings up into separate strings and concatenate them together, if you convert strings to arrays of bytes and then convert them back to a string at runtime, it's not going to stop anyone determined to crack your application, but it will slow someone down. It'll make it a little less obvious what the application is doing by simple means. The application bundle, so an IPA file is distributed by Apple, and that includes, as I mentioned before, the encrypted application binary itself, extra signing information, the metadata, and any resources that you bundled in. So any images, graphics, text files, content, etc. Your non-code resources are included in the clear. Music files, either original or licensed, are easily accessible. Someone can, so if you licensed some music or you made some music for a game that you're working on and you throw it in your application bundle, expect that a user is going to be able to open up the bundle, grab them, throw them on their iPad, throw them on an album, do whatever. Ping files in the bundle are not directly usable. So if you open up an IPA file and you open up a ping, it's not going to display. There's some optimization done to ping files before they're included in the bundle to help along iOS, but it's easy to convert those back to normal ping files. If you ship real content, such as sound files that are restricted by in-app purchase, expect that they're going to be available to the user without having to purchase them, because if they're in your application binary and they expand them, they may not be able to use them within your application without actually cracking the application, but they can still get at the content. There were at least some magazines when magazines were first put onto the App Store where all of the content was delivered in the application binary, and the use of it was restricted by in-app purchase. And if you're giving away all of your content, and if it's even remotely usable outside of your application, you're, like I said, giving away your content because you can't restrict it by in-app purchase at that point. And then along the lines of in-app purchase, you should always validate the receipts. So in-app purchase there's multiple steps to in-app purchase, but one of the steps that's moderately optional is when Apple sends your application a notification that the user has purchased a particular piece of content, you get a receipt. You can, at that point, Apple doesn't restrict access to anything within your application. Apple doesn't deliver any additional bits to your application as a part of in-app purchase. All they do is tell you, user A has bought this particular piece of your application. If you don't check that receipt, send a request back to Apple and validate that receipt, the request to your phone could have been forged, and you wouldn't know it, and you'd have no way of finding out. If you use the extra validation piece that Apple offers, you can check the receipt and make sure that it actually was a valid purchase request. Counterpart to your bundled data is your applications data that lives on the device. There's a tendency towards visible security measures. So a password to get into an application is a pretty obvious visible security measure. If you're storing all of the user's data in clear text on the device in the documents directory, then it's not very secure. You can mask out a password when you're asking for a password in the application, but if you just turn around and send that in clear text as part of an HTTP request, again, you're exposing that information, even though it seemed like it was secure. Get back there. And just because it doesn't act like or look like a web browser, treat any requests that you send over the wire using NS HTTP URL connections as basically a web browser. Consider all the same security measures that you would use if you were actually working within a web browser, because that's essentially what it is. Your application's documents directory is backed up during iTunes backups unless the user has actually ticked off the option within iTunes to encrypt the backups. Those are in clear text. So if you're storing any information in your documents directory, expect that's going to be visible to anyone, including the user, on their computer. Your application's temporary and caches directories aren't backed up. They're kept on the device, but they're still visible using extra tools. All three of those directories, as I'd mentioned, are browsable with a tool like iPhone Explorer. It's iPhone Explorer on the Mac. I'm not sure if there's a Windows version of iPhone Explorer specifically, but if there isn't, there's plenty of other tools that'll let you do it. There may be a tendency to store files that are sensitive in nature in the caches directory or in the temporary directory, since it's not backed up to the user's computer, but they're still fully visible to the user. And using something like iPhone Explorer, they're also modifiable by the user. Just to test this out, I used iPhone Explorer to grab a plist out of an application's documents directory, make a change to it, upload it back, and the application was still able to read that file and reflected that change to it. So the signing nor the inherent security on the iOS device doesn't prevent modifications or browsing of the documents directory. So it's just something you have to keep in mind with your applications. We covered that. So if you're storing a real-world example to that, if you've got a game and it's got a shared leaderboard and you're not using something like Apple's Game Center or OpenFaint, if you're actually just taking care of your own high score data, if you're storing your scores in your documents directory unprotected, and you allow for offline accumulation of high scores, and once the device is connected, it'll ship those up, you can turn off Wi-Fi to the device, go in, edit one of these files, put it back on the device, launch your application, and set your own score. You can do that for other achievements, for high points, for hit points. Like I said, anything that uses Apple's mechanisms is a little bit more secure if you're using their APIs, but it's still, if you're storing any information that you wouldn't necessarily want the user to change out of bounds, you need to protect it somehow. And you can do that by just really simple measures. As I mentioned before, there's a sliding scale of usability and security. And if you're spending most of your time addressing security issues within your applications, and your application is not security-centric, you're probably not spending your time in the best way for your users. But just some simple byte shifting or bit shifting. You can do full-blown encryption, but it has export ramifications. One common misconception as far as encryption, I get into this a little bit more, but one common misconception with encryption on iOS devices is if you're using the mechanisms that are built into the SDK, if you're using the encryption methods supplied by iOS, you're not adding your own, you're not rolling your own, that you're exempt from applying for the export permission from the government, and it's not true. Even though Apple is providing the SDK, you still need to get permission for your particular application for export compliance. And that includes SSL. SSL, except for a very particular use case, I think it's like one financial-based transaction in an application whose main purpose is not financial transactions, is all you can use SSL for without applying for export permissions. Excuse me. It's amplified. So one possible way to kind of hide or mask your files is, instead of shipping individual image files, individual sound files in your applications bundle, you can bundle them all into one file and use your own indexing scheme to read that data. There's an NS file handle that you can use, and you can actually index into one large data file to get your resources out. It's going to be pretty simple for someone to break that file apart if they wanted to, but again, it makes it a little bit harder, and if they're just casually browsing it, or if they're not very knowledgeable, it might not be worth them trying to take it apart to try to figure out where the files are. The keychain, you can use the keychain to protect data. Each application gets its own encrypted area. If an application shares a bundle identifier, I think it's a bundle identifier, multiple applications produced by you can share keychain information. Once a device is unlocked, all the applications are able to retrieve the data within their own keychain. And I know there have been some exploits against the keychain. I don't know what the current state of the current iOS version is as far as how secure the keychain really is, but it's Apple's preferred way of storing secrets for an application. You can also roll your own using either the encryption that's built in to the device or adding your own libraries. One way to get around situations like I mentioned before about the high score tampering is if you just do a simple hash, and I guess hashing unfortunately also falls under the export restrictions for encryption. But if you do a hash of all of your mutable files and store that anywhere, either in the clear or in a hidden area, and then use that hash to validate that the files haven't been changed, if you can't prevent modification, you can at least detect the modification of files and act accordingly. A straight hash would probably be pretty easy to figure out, but if you manipulate the hash even a little bit, it might be enough, again, to deter casual tampering. Not all security concerns are central to what you've got on the device itself and the data that's stored on the device. You want to use SSL or SSL plus encrypted data, even better, for over-the-air communications. Use SSL for communications when it's appropriate, but again, you have to consider the fact that it's going to require export compliance, and export compliance has gotten a little bit easier to get as time goes on. There's simplified forms. There's a URL that kind of talks you through all of the considerations and kind of talks you through filling out the short form, if there is a short form, if there's any form that's short enough to be worthwhile. But that'll help you get that acceptance from the government. If you use the SDK's built-in encryption, again, it doesn't absolve you from applying for that compliance. And it includes SSL except for that one financial consideration I'd mentioned before. If at all possible, your server side should be written with the understanding or with the assumption that the client is trying to get away with something. So the more that you can check bounds, check what you're receiving, because you control both ends of the communication, there might be an inclination to just trust what's coming from the client. Likewise, don't trust what's coming from the server, because a response could just as easily be forged back to your client as it is forged to your server. You want to evaluate and test your API as if somebody other than your application may try to use it. Consider leveraging some kind of a public key or asymmetric encryption to make delivering forged requests to either side at least a little bit more challenging. Again, we get into the situation of trying to protect the private key, but at least you can have some confidence that the communication that you're getting hasn't been tampered with. you have to assume that any URLs that you use within the application to deliver any premium content to your application will be URL hacked if they follow some readable, some human readable, human guessable format. So try to use hashes. You know, don't assume that a predictable URL pattern like video 1, video 2, video 3 will not be exploited somehow. You want to wrap any handling for protocols registered by your app. So an application can register a protocol type, a URL protocol type, and you can take requests into the application. So I believe Twitter has one. The mapping APIs on the phone have one, where you can trigger a call to your application passing in data. Assume that those URLs will also be played with, and different data will come into your application. So don't just assume that requests that you get are valid. Do some kind of sanity checking around the parameters you get through that call. Also consider the scenario of someone leveraging your APIs either locally on the device through those protocol requests, or your remote APIs on your server for malicious purposes. If they're trying to run a denial of service against your server, if they're trying to delete your user's data, if they're trying to mine your backend server for user data, if you have some way of looking up user data, and again, it follows some predictable scheme. If you've got a user info, even if it's public info, a user info where you pass in a sequential user ID, assume that somebody will write a script to just go one by one through that and try to mine your application for data. Users and end users' typical interaction with the security measures that you implement is going to be through your user interface of your application. You don't want to assume that you're going to have a single user. A phone, an iPod Touch is a pretty personal device. A lot of times it's going to be only used by your end user, but devices will still be used by multiple people. Also, you've got to assume that the device may be used by a child. If the parent gives the phone to the child to occupy them for a few minutes, assume that if you've got some kind of an e-commerce application, you probably don't want it to make it super easy to order things. Even if you assume that the user is the only one using it, may have disastrous results. So this is one that I've run into with an application. I don't want to bash any one application, but the way that iOS implements their backgrounding, it takes a second, sometimes more, to switch back to your application. So to make the response seem quicker, they take a screenshot of the application when it goes into the background. I have a password manager that has a timeout, and it's pretty good about timing out and taking you back to the lock screen. The only problem is it doesn't take into account the fact that iOS takes a snapshot of the last screen you were on. So if you have a, say, sensitive password up on the screen, you exit out of the application, you come back to the application 5 hours later, you go back into the application, it's going to show you the last state, it's going to show you all the information that you had on the screen that you would expect to be secure. About a second later, it's going to clear, and it's going to take you to the lock page. But you've already let any secrets that were on the screen when the application exited intact. You can get around that by killing the application manually, but it's pretty hard to remember to do. There's a call that you can intercept. You can listen for an event on the app delegate that will let you know when the application's about to go into the background, and you can clear the screen at that point. You should clear the screen. The screenshot happens after that point, but it's just one extra step that you can take to protect your users and protect their data. I guess in conclusion, I would say to remember to balance application security with usability. You don't want to make your application insecure, but you also don't want to make it so hard to use that it doesn't accomplish what you originally intended for it. You can't assume any of the resources stored within your application are protected, whether they're in the binary that should be encrypted or in the resources that are in no way encrypted. Protect every aspect of your application, at least the aspects that are feasible, not just the obvious ones, not just the really visible ones. And assume the threats will come maybe from the user, maybe from someone attacking the user, maybe from someone attacking your resources or the content within your application. So That's all I've got, and apparently I talked way quicker than expected. So does anybody have any questions?
What type of built-in encryption does the iPhone offer?
It offers, let's see here, I don't know the laundry list of mechanisms it has, but I know it has public key-based, pretty extensive, I can do a quick Google search for you. But I know it's got a number of cryptographic libraries built in. Like I said, unfortunately, if you use any of those, you do also have to apply for the export compliance. They have a little check mark when you're submitting the application that you say whether or not you use any encryption within your application. And your application can be rejected either during the review process or later if you use any of the cryptographic calls without declaring it there.
What is, can you limit it to only sale in the US?
I think that even if you do mark it as just within the US, they still make you answer that question. And there's a loophole in there, not really a loophole, but an exclusion where you can tell them that if you figure this out at the very end of your application development life cycle and you're about to go live, you're about to ship it, and you haven't done it yet, you can let Apple know that you've applied. You can write them a letter, send it to them, say that you've applied for export compliance, and they'll mark it only for sale within the US, I think Canada, and then they'll await you telling them that you received the full compliance to put it on worldwide. But I think even if you only intend to ship it in the US, you still have to declare that. And it's probably because of the worldwide reach of the App Store.
Do you still work at Sideways?
I do not. No, I started my own.
Tell me this.
Didn't come up.
The thing about the child running the e-commerce site.
Yes. Well, not the child running the e-commerce site, but the child using your application to buy a bunch of crap on the e-commerce site.
Personal experience.
No, just a devious. Well, when I was younger, I might have been, last week. Sir.
Is there a way to use the keychain or something like that such that it still is a temporary, say you have a secret that you don't want to be backed up anywhere, but you don't want to take the extra time to build something to encrypt and decrypt it. You want to just use the keychain-like system. Is there a way to mark your secret as don't back up?
Unfortunately, there isn't, and I actually ran into that. Things put into the keychain don't even go away from the device when you delete the application from the device, or at least they didn't in iOS 3. So if you've got secrets stored and your application doesn't clear them out before it's deleted, they'll stay on in the keychain. Now, the idea is that they can't be read because your application is gone, but if you reinstall the same application, they're still there.
And is there a best practice way to identify not only that the iPhone is the same iPhone, but it hasn't been reformatted or anything like that? Is there a best practice way to tell that that's the version of the iPhone the draft was installed on to begin with?
You could, let's see here. When you first launch, you can set a variable in the NS user defaults, and you can see if that's present, and if it is present, then you know that your application.
But that wouldn't be backed up somehow?
It would be backed up. So something that wouldn't be around if you deleted.
That temporary cache.
Doesn't every device that
It does. So.
But this is one step beyond. The device is formatted. I don't want it to be able to use the secret that was given to it.
Oh, if the device is, let's see here, you could. What could you do? Are you looking at protecting from something casually happening, or someone trying to get away with something and doing that?
It's more of the casual. I don't think
Okay.
you could stop somebody that really wanted to.
Yeah. So what you could do is you could populate either one of those other directories that put something in caches, put something in temporary, and then somehow use that against what you've got stored in the keychain, and you'd be able to tell if it had the if it had the same key or the same value in there. Sir.
I saw it at the presentation earlier this week on Android, and I'm wondering if you can comment on some of the security differences between the two.
I'm pretty new to the Android platform. I'm not sure if they've got anything that's similar to the keychain, but I would imagine any of the best practices as far as keeping data locally. I also don't know what, if any, encryption there is around the APK files that are distributed through the market. I imagine there's something there for some kind of piracy protection, but I would assume again that any of these packages that have been cracked or can be run with the piracy protection removed, any encryption that was done to your resources would have also been undone by that. As far as anything else, I would say that a lot of the tenets of assuming someone's going to try to abuse your server side and assuming that someone's going to get access to any resource files or anything that you put into your bundle, including any strings in your binary, are going to be in the clear to somebody at some point.
I've noticed some apps will have like a non-standard TLS connection to something, download something not a standard HTTPS, slash download this file, but like not a banned TLS connection. And some of them don't verify certificates; they just say no TLS, turn off anything.
Mm-hmm.
Can you talk about why that is? Is that a bad programmer? Is that because it's hard to do on the iPhone?
I can't really speak to why they wouldn't validate the certificate. They may be doing just a normal, like just an open TCP connection to some random port. Is that what you've seen, or?
It's actually TLS connection. It's using SSL.
Okay.
Make the connection.
But it's not validating the.
So if someone were to
That could be as easy as they tested against a self-signed certificate. They turned off the checking and they didn't think about the consequences of not turning it back on.
so it's easy enough to do.
I would think so. Yep. Anybody else? Well, thank you.